Welcome and hello. This is a support video for HEC RAS, and in this video I am going to demonstrate a split flow example. This will be a 1D steady flow, split flow, as well as 1D unsteady flow. All right, so let's go ahead and get started. One of the viewers wrote in a question to me asking please how to do a split flow example during one of the lectures. So this is a follow-up to that question. I'm going to start from the very beginning. I have HEC RAS up on the screen, so I'm going to go File, New Project. I'm going to call the project Support 14 and then click OK. All right. With the geometric data editor open down here, I can just close that and then open it back up, or edit geometric data. Same thing. Let's go ahead and sketch in a river reach. So I'm going to click on river reach and then just a single left click to add some curvature to my river here, and then double click for the final vertex. I'm going to name this river A reach 1 and then click OK. All right, the next step is to add some cross-section data. So we'll do that by clicking on the cross-section button. I'm going to add a new cross-section. So options, add new cross-section. This first section I'm going to add is going to be at river station 0. So I'll type a 0, click OK, and then paste in some cross-section data, or type it in. Either way is fine. Then I'm going to click Apply Data, and I see a preview of that data, the cross-section, looking in the downstream direction over here. You can toggle that side view off and on with this little button right here. Okay, so that looks fine. Now I need to specify the distance to the next downstream cross-section, which of course is 0. Manning's end value, I'm just going to make up some typical numbers here, like 0.05 and 0.03. And then the left bank is at station 60, the right bank is at station 150, which is here and here. And then when I click Apply Data, that is all saved and good to go. All right, so that's my cross-section at river station 0 at the downstream end. I'm going to create one more cross-section manually up here at the upstream end, and we'll say that's 1,000 feet upstream. So options, copy the current cross-section. For the river station, I'm going to say it's 1,000, okay, and then click OK. Now I have basically a duplicate cross-section. Here's river station 0 cross-section, river station 1,000 cross-section. What I want to do now is just make a few changes to this cross-section at river station 1000. For instance, I want to change the distance to the next downstream cross-section, of course. That's going to be 1,000 feet. This model is being built using US customary units or English units. So keep that in mind. And I also need to increase the elevation. Now right here, the invert is 32 feet, but let's say we're going to increase the invert by 2 feet at the upstream end of this reach. So I could either type in new numbers, 50, 42, 42, 34, and so on. Or another way to do that for all the data points is just go options, adjust elevation, and then type in a positive or negative number, whatever you want that invert to adjust to. Or really, it's the entire cross section, not just the invert. I'll type 2 and click OK, and then boom, all those numbers have incremented by 2. And just take note that the invert is no longer 32, it's now 34. Okay, so I'm going to go ahead and click Apply Data. And then if I close the cross-section data editor, we now see the cross-sections for the two that we defined. The little red dots here, I don't know if you can see them very well, but those are the bank lines, the stations for 60 and 150. All right, one thing I want to do before adding a second split, a second river to divert the flow away from the main river, is to add intermediate cross sections. So to do that, I'll go up to the Tools menu in the Geometric Data Editor window, Cross Section Interpolation, the first option here, within a reach. And then this is going to be for the entire reach. So I'll just type in the distance between cross sections, interpolate cross sections, and close. So this is a linear interpolation. All of the cross sections that are now created between 0 and 1,000 are basically the same shape, but are just going to slightly decrease in elevation. All right. So that looks good, which means the invert at 500, let me open that up again, should be 33 because it would split the difference between 32 as an invert at river station 0 and an invert of 34, which is the invert at river station 1000. So let's just go there and check it out. Here is cross section at river station 500. The invert is 33. All right, that's important because if we're going to create a second river to split the flow, then it makes sense to basically match the invert values for those two rivers at that one location. That will eliminate the chance of any problems with the flows. Any instabilities will be reduced if we go ahead and match the inverts, or better yet, add more cross sections close to that location. But I think 100 feet is good enough for this to still work. So let's go ahead and do that. Now, zooming in and zooming out of this map is kind of hard with the current extents. This is a 1D model. I'm not using a terrain layer. It's not geo-referenced. It just uses its default 0 by 1 grid. So if I go to view and then set schematic extents, you can see what I'm talking about, just 0 to 1. So I'm just going to zoom out a little bit, change the zeros to a -1, change the ones to a 2, and then boom, it gives me a little bit more room to navigate. All right, so that still means the length of the reach is 1,000 feet because the numbers we type in will override. But just so as far as navigating, it's a little easier to work with. Okay, what I'm going to do is come down here to River Station 500 and then sketch another river or a diversion or a split flow, if you will, to divert some of that river water away. So I'm going to click on this river reach tool here. So let me zoom in a little bit more. Okay, river reach. And then right here at cross section 500, as close as I can, do a single left click. Again, I'm sketching upstream to downstream. So I'm just going to slowly divert this away. And then, so I'm just trying to make it about 500 feet as well, maybe right there. So double click. This is not going to be river A anymore. This is going to be river B. So now I'm naming this new river. River B, reach 1, that's good. The next question here is, do I want to split River A into two parts and create a junction here? And the answer is yes. So now it's asking me, what do I want to call the downstream reach? The upstream is going to maintain its current name of River A, reach 1. But downstream, I'm going to call this River A and then reach 2. I have a bunch of spaces after River A for some reason. River A reach 2 and okay. The last question here is, what should I name the junction? Enter a junction name at this location of River Station 500. Anything would be fine. I'll just call it J500. Okay, so we are good to go. What we have now is the junction. It's in place, J500, as well as our new River B reach 1 and renamed River A reach 2. Now, River B reach 1 doesn't have any cross sections. So let me go ahead and basically duplicate the work we did with River A and give River B some of those same cross sections. We don't have to do as much work as we did the first time because, again, we can use the copy feature. I'm going to go to River A, reach 2, and go right here, which is the downstream cross section at River Station 0. And I'm going to copy that to be River Station 0 at River B. So options, and then copy the current cross section. And I'm going to copy it to River B, reach 1, River Station 0. Okay, so that's good right there. Next, what I want to do is copy River Station 500, that cross section data, to match the exact same top of River B reach 1 river reach, which is also going to be at 500. So let's go ahead and find the source, River A, and I believe I'm not sure if it's reach 2, 500. There we go. So I'm going to go options, copy current cross section. And now this is going to be River B, reach 1 and 500 and okay. Now the only thing I need to change here is change this 100 to a 500 because the next downstream cross section at this moment in time on River B, reach 1 is 500 feet downstream at the end of the reach. So boom and boom. I think we're good. I'm going to click apply data and then close. All right, very cool. So we have two 500 River Station 500, which should be right around the junction, and then this cross section at River Station 0 on River B reach 1. As before, I'm going to add some intermediate cross sections. So let's do that just like we did the first time. Tools, cross section interpolation within a reach. And then, yeah, River B and reach 1. That looks good. And I'll just say 500, interpolate, and close. All right, so I think we're done with the geometry. I'm going to go File, Save the geometry data. I'm just going to call this base. and then OK. That looks good. After that, we need to actually add some flow. So up here at the main GUI for the files, I'm going to click on Edit, Steady Flow Data. And now we have to specify three different flow rates. We have the flow rate at the very top of the river. We'll just say that's 800 CFS. And then we could say it's an equal split of 400 and 400 down between the downstream end of river A and river B. So the flow has to split, and we're going to make those assignments right here. Now, it may not be equal. In fact, in reality, it won't be equal. We could say it's maybe you could say it's 425 and 375. I'm not sure exactly what it's going to be. And in a 2D model, it will actually be dictated by the model and the terrain and a few other things. But in 1D steady flow, that's for us to specify. So what we're going to do in the remainder of this support video is run the simulation, look at the results, and then we're going to run an unsteady flow simulation. However, I'm going to set the flow to be steady, and you'll see what I'm talking about there, because we're going to let HEC RAS determine what the split actually is. Okay, so the last thing I need to do here for the flow data is click on Reach Boundary Conditions. And as you see, we have the junction connection already in place at J500. That looks good. This is going to be a subcritical flow, so I just need to specify the downstream boundary condition. I'm going to use normal depth, and I'm just going to say the slope is equal to the channel bottom slope. So 0.002. That looks good. And then OK. File. Save the flow data. I'm going to just call this steady, and then click OK. All right, so we're done with that. Now let's go up to, save, and then run steady flow analysis. Click on subcritical. So we have our base geometry and our steady flow data at 800 CFS with that defined split of 425 and 375. I'm going to go File, Save the plan. I'm going to call this steady as well, and then click OK. For the short ID, I'm going to call that steady, and then click on Compute. All right, so the computation is done. Let's take a look at some of the results. To do so, we'll click on View menu and then Cross-Section Data. So what we're looking at here is River B, Reach 1, River Station 500. What I'm seeing in this dropdown are all the cross-sections associated with Reach 1, and these are all pretty much going to look the same. So there they are. And then if I wanted to look at River A, I have Reach 1 and Reach 2. So in Reach 1, I have cross-sections 1,000 down to 600, or it's really down to 501, I believe, on the stationing. And then for Reach 2, that's River A, Reach 2, our cross-sections range from 0 up to 500. So we can go ahead and look at the plot by just looking at the geometry and the water depth. But if we actually want to look at the numbers itself, we can go up to View, Profile, Summary Table. And at the moment, we're only looking at Reach 2, which is River A, Reach 2. But if I wanted to get all of the 15 or so cross sections, 16, I would want to go up to Options and then Reaches. River A Reach 2 is currently selected. We'll just click Select All. So River A Reach 1, River A Reach 2, River B Reach 1. That looks good. I'll click OK, and then boom. Now we have the river name in the far left column, and then the reach, and then the river station right here. So it gives us sort of a guideline on exactly which row of data we're looking at here. So for instance, upstream of the junction, that's River A Reach 1. That's these cross sections right here. We have a flow of 800 CFS. We have the invert, we have the water surface elevation, and then all the rest of the data. After the split in River A Reach 2, we have the flow of 425 CFS with that data. And then the diversion, the split flow over into River B, we're calling it. That data is up here. The flow rate is 375 as I defined it in the flow data. All right. So again, I feel that's a little unsatisfying because we're not letting HEC RAS determine what the flow is. So that's what we're going to do now. And I'm going to close the results. I'm going to go up to Edit and now Unsteady Flow Data. In this dialog box, we need to specify the boundary conditions. The downstream boundary conditions for both River Station 0 on both rivers, we're just going to set it to normal depth again. So I'll say normal depth and 0.002. That's the channel bottom slope. And one more time here for river B, normal depth, boom, and okay. Now for the upstream boundary condition, this is going to be our constant 800 CFS flow. So I'll click on flow hydrograph and I'll enter 800 CFS for every time step. Now, obviously for unsteady flow, we have the freedom to change the flow rate and look at the fluctuation and how the system responds. But for this particular support video, I was just going to do a constant 800 CFS for maybe a 24-hour simulation. So over in my Excel, I'm going to grab that data. And then back in RAS, I'm going to highlight those cells, Control V to paste. There's the data, plot data, 800 CFS. It's constant. And I'll also leave this radio button for use simulation time on a 1-hour time step, just as it is, just with the default settings. So don't worry that the date time is wonky right here. It's going to use simulation time, which is what we're going to define right now. I need to save the unsteady flow data. I'll call that unsteady. And then I'm going to click on the unsteady flow analysis box. For base and unsteady, that's the two files I need for a plan. So I'll do file, save the plan. This will be called unsteady now. And then unsteady again for the short ID. I'm going to toggle on the geometric preprocessor, unsteady flow simulation, and post processor. I'm going to make up a date. It just needs to be any date in history, basically, or I suppose the future. But it needs to be 24 hours, not longer, because the flow data is only 24 hours worth of data. I'll just say it's going to be the first day of the year 2022. Okay. And then down here, I'm going to make this a little bit more precise and shorten up the time interval from 1 hour to 15 minutes for the flow hydrograph and the detailed output. And then, yeah, I think we're good there. So file, save the plan, and compute. Okay, so that finished up. Let's go ahead and take a look at the results. View. Let's go ahead and look at the XYZ plot. This is fun. We'll look at the numbers in just a moment. But here you can see the perspective plot by rotating the view a little bit better. This is a little better when we have unsteady flow. I mean, truly unsteady flow with some structures. And then we can also look at what I really want is the profile summary table. All right, so here are the numbers. We start off with 800 CFS. That makes sense. And then it looks like oh, you know what? This particular profile is the max water surface elevation. I need to change that to, well, any profile would do, but not the max. Let's go to the very end of the simulation where supposedly equilibrium has been reached. And then I'll just double click OK. And wow, it looks like it's an even split between 400 and 400. Okay. You know, I did this one time in preparation of the support video, and it was like 391 and 409. So it was pretty close to 400 and 400, but this looks like it's an exact 400 and 400, which means I must have just absolutely nailed the location when I set up this particular junction at River Station 500. But my drawing skills are not always perfect, and I guess they just happen to be, or at least within tolerance for this particular exercise. So anyway, a little anticlimactic. I thought there would be some different numbers here, but sure enough, we have truly a split flow based on the hydraulics built into the HEC RAS computation engine. All right, I hope that video was helpful.